Hello, this video is to show how we could use a JSON file in MathSpring to create and generate uh, hints in usable math, and also be able to create glossary, uh, which is per problem, and also be able to offer translation abilities and any other grid statements that are currently being used within MathSpring. So I would like to first make this into a 5-stage process, and for that I'm using this Google Jamboard. Um, so I'm opening a new sticky note. For this purpose, I'm going to use a blue sticky note. I'm going to do two to just give you an outline as to what I'm talking about. So I'm color coding these because these are later going to be made into like a stage based situation. And so the first stage that we're going to focus on is on the tool itself, which is the MathSpring intelligent tutoring system. So when I log into this system, MathSpring, all right. So when I log into the system, I am able to see a lot of math word problems. These are word problems that are either multiple choice or fill in the blank type, right? And these are the ones. These are the ones that um, the students in Massachusetts, particularly, use in their math classrooms. These are taught by real teachers, and the students use the system to develop their math skills. And we did this for a long time, and we have all the literature showing the various kinds of research studies we have conducted with this, and then how the learner has improved after using MathSpring, right? And we know from research also that the very recent research where we used AI to create hints within of MathSpring, and the hints were really really amazing. If anybody's interested, they should look up our recent work on this. But the what happens when I am on that math interface? I should be able to create a real-time JSON file. In this file, which I already have access to, this file gives me a lot of information per problem. What do I mean by that? So it's going to give us information such as the question type, the question itself, and its ID, number of hints that are assigned to this particular problem. It gives me the common core standard. It gives me the order of hints, because in the teacher dashboard or in the authoring tool we know that it's not necessary sometimes that hint number 3 appears it does not necessarily appear in position number 3. So a third hint could also appear in the first part on demand click through by the learner. So so I set order of hints for that purpose. But if it's not a feature in MathSpring, that's fine also, because I'm using this with another tool of my own, which is usable math. But order of hints, it also gives me if there are any videos. I'm going to call it media, including photos, videos, YouTube videos, or videos that we have created, or animations that we have created. It tells me if it's present or not. If it's present, it tells me the path. That's all I need. That's all that comes in a JSON file. And it also gives me the text of the hints. It gives me, if I were to go to a sample problem, we can test it out right now. This is only a sample problem. may not be since I'm logged into a.
I have the same problem in my own computer.
I just muted it. Okay, so it's going to give me the number of hints. It's going to give me if there's a video example or if there's a formula. It also going to give me information such as the common core, the problem ID. Did I write problem ID? Problem ID, yes, common core standard. And then it also going to give me anything related to the topic and the teacher. Yes, topic and the teacher. Topic name and teacher ID. I don't know what that ID is especially, but a teacher can have a name to their class. So I'm going to call it topic name, class name. That's it. Because the teacher gets to choose the class name. It's their wish up to if they want to use a semester-based naming convention, or they could just use their own name. That's how I see it in both ways. So there's that. So that is going to give me all this data. Right now I already have access to this data. So now I'm going to create another note, but I'm going to create another color, and this is going to be right there. So essentially what happens is we look at the one in the center line. I'm going to make a row, and that tells us where we stand. Let me arrange this. So okay, so this is what happens when, based on our previous study, which was looking at how large language models could be tailored to K-12 math contexts. In that same method, in the same methodology, we are scaling this by using the latest large language model that Facebook just announced. It's called Llama, and then I'm going to go and search. This is it. So, and this is a recent. Is this the? Yes, this is the paper that I was talking about. I did not read this. I bet I had something else. This is the. Don't know. Okay, no problem. I'm going to look at it. But we are going to use Llama because it is, according to their description, has a more humane sort of an approach because of the Facebook dataset, which is more conversational because it's between friends and families. Unlike Reddit, which ultimately became the dataset for many large language models, and Reddit is not really a friend-family sort of a social network, but instead a stranger-to-stranger interaction, sort of a community-based crowd voting system, right? And it's completely different from Facebook, and that's why you see the differences. So I say that because the recent Llama 2 launch, which I tested out from the Hugging Face and the Perplexity AI sample, we supplied that file along with a prompt of a category. So what does this mean? It means that we are sending the JSON file in real time, and then it is being supplied to it is going to be packaged with a prompt. This is a prompt that is in one way linked to our output, because according to prompt engineering, we know that we know that if we were to use proper prompt structure, we can have the most accurate and not as much hallucinations in the generated text. You see what I'm saying? So you asked Dick to do exactly what you gave it a prompt that is taking in the action and giving you a output. Okay, so a prompt, in this case, we are going to use a hint prompt. The prompt is in the paper. In the same way, we are also going to use the default conversational AI. We don't have to use any techniques for this. It's already built in. I made a little slideshow that I'm going to show later on in this video. Okay, the next feature that we can also include is borrowed from the Robert Milloy and Sharon Edwards' formality system, which is the version 1 of this. And in that system, which we closed down because of legacy software issues, but there we found out that there is glossary per problem. So a learner can click on the glossary and then see what each math operation meant with examples and GIFs and animations. This is multimodal. We need this. That's what I came to know about. That's when I came to know about this glossary, right? And that is really important, just in case if somebody is not aware of that math concept, they can go and then they can create a glossary. They can look up the glossary. And then comes the Maria Luisa and Yvonne Arroyo's bilingual. I write this because I don't know what to exactly call this. I don't want to maybe remove the names. I don't know. I say this because we now have the ability to translate, right? We now have the ability to translate on demand without asking for anything. You just give it the real problem and the prompt to translate, and then you get the prompt and you get the output that is translated and within context. Previously, you needed to hire somebody and then who will go and then do the translation and then have a teacher review it and then you pass it. But now you're able to cut it down without any effort. This is another purpose of this research in overall. And then I want to take this, the last one is not really, I did not really look at this from MathSpring perspective, but after working on usable math, I came to know the purpose of grid statements. So grid statements are really important, and we know that these are of high regard in by Angela Duckworth. We already use this in MathSpring and also in usable math, so we have that ready. So the prompt is tailored according to the outcome of the output, but the prompt can always, it has to go through the black box, right? And for that reason, I'm going to create a new color, and then this is the color that essentially is the Llama 17 billion parameter model, which we are going to use the open source version that is commercially free if you have less than I know I don't have to write this, but if you have less than, I believe, 700 million users or less, it's free. Otherwise, the need to check. I don't know if this is true. I don't know if this is really 700 million users or less. I just came to know about this from the ChatGPT Discord server because everybody's talking about it. in the professional learning community, which is completely hosted on Discord. So, but coming back to this, so the JSON file goes to the Llama model, which is the public version that is free for us, and then we are going to use that version to create or generate outputs of the desired nature. Now all this will, the last one, be another color, and this is coming from essentially the idea that children, young learners, and who are middle school and high school and adult learners, math learners from other languages that are non-English would sometimes be, it would be nice to them if there is a feature that would allow for them to listen to the problem spoken out loud in their language. For example, Holyoke, where we did the experiments many times, where we tried this. Yvonne tried this in Argentina. They tried that in Holyoke this summer, or yes, this summer, which Daniel and I also contributed to. In that cases, we'll use a public text-to-speech API such as, I don't know if Whisper only does transcribing, but I know for sure the Pi model does do natural language speaking ability. It's really amazing. I don't know if there's anything close to Pi, but not this Pi. I'll have to find the Pi. So Pi AI. Okay, this, sorry. It's called Pi AI Talk. Okay, now this is the model that I'm talking about. So for example, I'm going to just put that here as Whisper and Pi.ai. That's it. So what the output is directly going to be displayed on the front end through a simple interface. This is the full package that runs in real time on our existing AWS infrastructure, where we can also host this real-time data model that Facebook is talking about. There is one last thing that I need to show as to how we are envisioning this to happen. And for that, I'm going to open a new tab. I'm going to go to Canva. And then from Canva, I want to show a recent screenshot. This is UMassAmherst. Okay. So I'm going to go full screen. For just the sake, I know this is not MathSpring. This is something completely different. But I would like to just remind you that this is a demonstration only. This is not the real production version. It's a mock-up to have initial feedback and show how I'm envisioning it, so somebody else can build it. At least in terms of the design wise, this is how it must be, because this is what I'm seeing in the field, where everybody is having their own AI bots. But if you notice, in the top, this is the math problem, which is a multiple choice, hints. These are all click through system, and I'm showing this after the child has answered the right answer. So this is like an immediate screenshot of that problem after the child has answered the math puzzle. Bottom right corner, I see a small animation. This is the animation that I'm talking about that will run the stage-wise structure I just showed. So this is going to be a persistent icon that we could use, that I really would like our Daniel to lead, because I love her work with creating animations with the characters. So when I tap that, it shows me a chat interface. This is in real time looking at the JSON file and adapting the conversational part of it based on what we saw here. It offers glossaries, it offers the translation abilities, it offers the grid statements, and it also does multilingual through the same interface. For this purpose, I'm going to make a copy of these two and make adapt them to fit the purpose of MathSpring, because this is not MathSpring, this is usable math. So I go back to the MathSpring math interface, which is providing us with the JSON file, and I'm going to go and make sure I hide my bookmarks, close my tab bar, and then I would like to take a screenshot. And for that, I'm going to go to screenshot, and we take I'm going to take retake the screenshot to cover as much as possible, like that. Okay, so I don't want to put the character learning companion because I may have to find the icon space that I want to put it at the very bottom right corner, and for that reason I'll put it like this. Okay, so I have this. Now I'm going to say save and open my tab bar, go back to usable, the Canva template, and then I'll go to uploads. I can close this, and then from uploads I go to the problem itself, and then what I'm going to do is just drag drop that here, remove this full thing, and then just drop this here. So essentially we're going to push now this is hidden. I don't want to do that. And then so what I'll do is I'm going to right click, go to layer, and then I'm going to go to send back. So I push that back to reveal my character. This is for now a sample markup. I will just directly would like to make a copy of this same sample markup and then go to this other screen which I already made a copy of, so I don't need this one. All I need is just this. So I'm going to select everything. I'm going to select everything, right click, and then I'm going to say group. Okay, now we can have as many groups as possible. And this is the same group that I would like to copy. This is the position of this. I moved 3 to the left, but the position is still being maintained on the original, which is this. So I'm going to just select that, copy, but I come back to this slide and then just paste this. But before I do that, let me just remove this old one and then just paste this. So now this makes sense. Look at this. So this is the screenshot of the problem with the AI readily available on top. And then there is the AI which, when the learner clicks, automatically looks at the JSON, processes it in our existing infrastructure on AWS or on device, depends on how we want to do that, but I think we should do that on our AWS. And that is going to provide outputs in a way that is personalized to the problem, and then it also is going to give us the ability to have other features that we do not have access to currently. And on top of all that, we have the ability to use systems that are similar to Pi. There are many that are open, or we could just use them. If somebody made it, there will be an open source version in just a couple of weeks. That is my belief. Right now, I don't know if it's possible to use this, but if it is there, which means it's possible, and we can use any open one. I'm pretty confident now this is coming into browsers, and you don't even have to have a a dedicated API for this. Browsers do it by default. So you just pass all this to the browser, and the browser does it. I don't know if we need to talk about that at this time, but this is the mockup that we would like to present. And that concludes the 5 stages of the research methods for the IES AI grants. Thanks for watching. Bye.